Thermal conductivity in MKS units is kilo calories meter per hour meter square degree second. Unit of thermal conductivity in SI units is B and C. B in the joule meter Kelvin seconds, watt per meter Kelvin. Thermal conductivity of a solid metals with rise in temperature normally decreases. Thermal conductivity of non-metallic atmosphere amorphous solids with a decrease in temperature decreases. Heat transfer takes place as per second law of thermodynamics. When heat is transferred from one particles of hot body to another by actual motion of heated particles is referred to heat transfer by conduction. When heat is transferred from hot body to cold body in a straight line without affecting the intervening medium, it is referred as a transfer by radiation. Sensible heat is heat required to increase the temperature of liquid or vapor. The insulation ability of insulator with the presence of moisture wood decreases. When heat is transferred by molecular collisions, it is referred to a heat transfer by convection. Heat transfer in liquid and gases takes place by convection. Which of the following is case of heat transfer by radiation? Heat received by a person from a fireplace. Heat is closely related with temperature. Pick up the blank case. Heat falling from one side to other depends directly on thickness. Metal are good conductors of heat because their atoms collide frequently. Which of the following is case of steady state heat transfer? None of the above. Total heat is the heat required to convert water into steam and superheat it. Cork is a good insulator because it has porous body. Thermal conductivity of water is general with a rise in temperature, may increase or decrease depending on temperature. Thermal conductivity of water at 20 degrees centigrade is of the order of 0.51. Temperature of steam at around 540 degrees can be measured by thermocouple. Thermal conductivity of air at room temperature in kilometer per hour is the order of 0.02. The time constant of thermocouple is the time taken to attain 63.2% of the value of initial temperature difference. Thermal conductivity of air with rise in temperature increases. Heat flow from one body to other body when they have different temperature. The concept of overall coefficient of heat transfer is used in heat transfer problems of conduction and convection. In heat transfer conductance equals conductivity kilo per hour divided by centimeter thickness. The amount of heat flow through a body by conduction is dash, all of the above. Which of the following has the least value of conductivity is air? Which of the following is expected to have highest thermal conductivity is solid ice? Thermal conductivity of glass wool varies from sample to sample because of variation is all of the above. Thermal conductivity of material may be defined as all of the above. Which of the following has a maximum value of the thermal conductivity? Aluminum. Moisture would find its way into insulation by vapor pressure unless it is prevented by a vapor seal. Heat is transferred by all three modes of transfer by the conduction, convection and radiation dash boiler. According to Prevost's theory of heat exchange, all bodies above absolute zero emit radiation. The heat ratio of heat flow Q1 by Q2 from two walls of same thickness having their thermal conductivities are K1 equal to K2 will be 2. Heat transfer by radiation mainly depends upon dash all of the above. Thermal diffusivity is dash a physical property of the material. Thermal diffusivity is a substance is proportional of thermal conductivity K. Unit of thermal diffusivity is a meter square per hour. Thermal conductivity of wood depends on all of the above. A convection heat transfer from hot flue gases water tube even through flow may be turbulence laminar flow region close to tube. The heat transfer through this takes place by dash conduction. Film coefficient is defined as dash thermal conductivity by equivalent thickness of film. Heat conducted through unit area and unit thickness per unit time when temperature difference between the opposite phases is unity is called as thermal conductivity. In the heat flow equation Q is equal to K of T1 minus T2 by X, then in terms of X by K is known as thermal resistance. In the heat flow equation Q equal to K of T1 minus T2 by X, the terms of T1 minus T2 by X is known as temperature gradient. The rate of energy emission from unit surface area through unit solid angle along a normal to the surface is known as intensity of radiation. Emissivity of a white polished by a compression to a black body is lower. A grey body is one whose absorptivity is equal to its emissivity. Iscard number is expressed by velocity of fluid square by specific heat at constant pressure and temperature. Two balls of same material and finish have their diameter in ratio to 2:1. The both are heated at same temperature and allowed to cool by radiation. Rate of cooling by big ball compared to smaller one will be in the ratio of 1:2. Grashof number is expressed by dash. Inertia force into buoyancy force by viscous force. A non-dimensional number generally associated with a natural convection heat transfer is dash. Grashof number. LMTD in case of counterflow heat exchanger as compared to parallel flow heat exchanger is dash higher. In heat exchangers, degree of approach defined as the difference between the temperatures hot medium outlet and cold water outlet. In counterflow heat exchangers, both the fluid at inlet are in their hottest state. A steam pipe is to be insulated by two insulating materials put over each other for best results. Better insulation should be put over pipe and better one over it. Nusselt number is expressed by coefficient of heat transfer inside diameter by thermal conductivity. Fourier's law of heat conduction is valid for one-dimensional cases only. According to Kirchhoff's law, the ratio of emissive power to absorptive power for all bodies is same and equal emissive power of perfectly black body. All radiation in a black body are observed. According to Kirchhoff's law, the ratio of emissive power of absorptivity for all bodies is equal to the emissive power of dash black body. The concept of overall coefficient of heat transfer is used in case of heat transfer by conduction and convection. The unit of overall coefficient of heat transfer is kilocascal per meter square hour square. The heat transfer equation Q is equal to sigma A T power of 4 is known as Stefan-Boltzmann equation. Joule second is the unit of Planck's constant. The value of potential number is the air is about 0.7. The value of the wavelength for maximum emissive power is given by Wein's law. Potential number is expressed by dash. Specific heat into viscosity by thermal conductivity or molecular diffusivity of momentum by thermal diffusivity. The mean temperature difference in case of counterflow compared to parallel flow will be dash more. The energy distribution of an ideal reflector at a higher temperature is largely in the range of shorter wavelength. The total emissivity of polished silver compared to black body is dash very much lower. According to Stefan-Boltzmann law, ideal radiation emit radiant energy at a rate of proportional to dash fourth power of absolute temperature. Which of the following property of air does not increase with rise in temperature density? The unit of Stefan-Boltzmann constant is watt per centimeter square kilo for 4. In a free convection of heat transfer, Nusselt number is function is Grashof number and potential number. Stefan-Boltzmann's law is applicable for heat transfer by radiation. The thermal diffusivity for gases are generally more than those for liquids. The thermal diffusivity for solids are generally more than those for liquid gases. Thermal diffusivity is expressed by relation K by rho Cp. Thermal diffusivity of substance is dash all of these above. If two surfaces are area d distance L apart m material having thermal conductivity K at temperature T1 T2, the heat flow rate through will be Ka by L T1 minus T2. The ratio of emissive power and absorbed power of all bodies in the same and equivalent emissive power of perfectly black body. This statement is known as Kirchhoff's law. According to Stefan's law, the total radiation from a black body per second per unit area is proportional to T power of 4. According to Planck's law, the wavelength corresponding to maximum energy is proportional to 1 by T. According to Wein's law, the wavelength corresponding to maximum energy proportional to absolute temperature. Depending on the radiating properties, a body be white when rho equal to 1, tau is equal to 0 and alpha is equal to 0. Depending on the radiating properties, a body will be black when tau equal to 0, tau is equal to 0, alpha is equal to 1. Depending on the radiating properties, a body will be objective when tau is equal to 0, alpha plus 0 is equal to 1. When heat transfer equation dou square T by dou x square plus dou square T by dou y square plus dou square T by dou z square equal to 0, Laplace equation. If the inner and outer surface of hollow cylinder having radius R1 R2 temperatures T1 T2, then the rate of radial heat flow will be dash 2 pi Lk T1 minus T2 by log of R2 by R1. Two plane slabs equal areas and conductivities in the radiation 1:2 held together. Temperature in between the surfaces are T1 T2. Temperature between two surfaces decided to T1 plus T2 by 2. Then the thickness should be in the ratio of 1:2. The heat flow rate through parallel walls of thicknesses L1, L2, L3 having surface area A1, A2, A3, thermal conductivity K1, K2 respectively. First and last walls maintain thermal temperature T1 and T1 minus T2 by L1 by A1 K1 plus L2 by A2 K2 plus L3 by A3 K3. Inner and outer walls of hollow sphere having surface area of A1, A2, inner and outer radiating temperature T1, T2, heat flow will be K root of A1, A2, T1 minus T2 by R2 minus R1. At thermal equilibrium, absorptivity is equal to emissivity. The ratio of emissive power of a body, the emissive power of a perfectly black body is called as emissivity. The wavelength of the radiation emitted dash A and C. Shown in the above figure, temperature across thickness of material with different thermal conductivities under steady state. Curve C will be applicable when thermal conductivity of the material is very large. Figure A, above figure A, curve A will be applicable when there is thermal conductivity of temperature is the dash increasing with increasing temperature. A figure above curve B applicable when the thermal conductivity of the material decreases with increasing temperature. B applicable when the material conductivity of material is very large. The critical radius of insulation of a cylindrical pipe is thermal conductivity of insulating material by heat transfer coefficient of outer surface. The total emissivity power is defined as the total amount of radiation emitted by black body per unit time. The critical radius of insulation by the spherical shell is the 2 into thermal conductivity of insulating material by heat transfer coefficient of outer surfaces. The ratio of the energy absorbed by the body, total energy falling on its called is absorptive power. LMTD for a heat exchange is given by delta T2 minus T1 by log of delta T2 by T1. The amount of radiation mainly depends on all of the above. The emissive power of body depends upon all of this above. ఈ విధంగా ఉంటే రేడియేషన్ will take place mainly radiation. Absorptivity of a body will be equal to emissivity when system is under thermal equilibrium. In regenerated type heat exchanger, heat transfer takes place by flow of hot and cold fluid alternating over a surfaces. A perfectly black body is one which absorbs heat radiations of all wavelengths falling on it. Planck's law holds good for black bodies. Depending on the radiating properties, body will be transformed when dash rho equals 0, tau is equal to 1, alpha equals 0. Thermal radiation extends over the range of 0.1 to 100 mu. A grey body is one whose absorptivity varies with the wavelength of incident ray. Effectiveness of heat exchanger is defined as th1 minus tce by th0 by thi. Up to a critical radius of insulation, convection heat loss will be less than conduction heat loss. For infinity parallel planes with emissivity E1 and E2, the interchange factor for radiation from surface 1 to surface 2 given by 1 by E1 plus 1 by E2. A heat exchanger with heat transfer surface area A and overall heat transfer coefficient U handle a fluid's heat capacity C max and C minimum. The parameter NTU, number of transfer units used in the analysis of heat exchange specified by AC minimum by U. A composite slab has two layers, different materials with thermal conductivity K1, K2. Each layer had same thickness. The equivalent thermal conductivity of the slab would be K1, K2. A long semi-circular duct is shown in the given figure below. What is the shape factor F22 for this case? 0.36. Which of the following diagram represent correctly gas counterflow heat exchanger is the temperature area? The ratio of thickness of thermal boundary layer, the thickness of hydrodynamic boundary layer is equal to potential number where n is the minus 1 by 3. The following parameter 1, 2, 3, 4. Infinity parallel planes is the 3, 1 by E1 plus 1 by E2 minus 1. Completely enclosed body larger compared to enclosing body 1 E1. 2 rectangular with dash 2 E1 E2. Common conventional cylinders is the 4 minus 1 by E1 plus A1 V2 1 by E2 minus 1. Time constant of a thermometer of a radiation or h2 pi or L by pro CV. Biot number for a sphere of radius h0 by k solid. Critical thickness of insulation for a wire of radius to k by h. Nusselt number for a sphere of radius 1 k h0 by k fluid. Heat pipe is widely used nowadays because it reacts as conductor and insulator. Regenerative heat exchanger, hyperbolic curve, direct contact heat exchanger, water cooling tower, conduction through a cylindrical wall, logarithmic curve, conduction through a spherical wall, Nordstrom air heater. In current carrying conductors, if radius of the conductors is less than the critical radius, the addition of electrical insulation desired, it reduces the heat loss from the conductor and thereby enables the conductor carry higher current. A pipe carrying saturated is converted with a layer of insulation and exposed ambient air. The thermal resistance of the shown in the figure R stream, R pipe, R ins, R A. Which of the following statement is correct? This regards R stream and R pipe are negligible as compared to R ins and R air. Windows glass is the emissivity independent of wavelength. Gray surface is the transparent to short wave radiations. Carbon dioxide is the emission and absorption limited to certain Hz wavelengths. Radiosity is the rate of which radiation leaves a surfaces. Momentum transfer is the kinematic viscosity. Mass transfer is the diffusion coefficient. Heat transfer is the thermal diffusivity. Heat exchanger with heat transfer surface area and overall heat transfer coefficient. U handles two fluids heat capacity C1 C2 such as C1 greater than C2. The NTU the heat exchanger will be AU by C2. Heat transfer through fins 2 and 4 2 and 2 4 correct. Addition of fin to the surface increases the heat transfer if root of HA by Kp less than 1. A cube at high temperature immersed at constant temperature bath loses heat from top, bottom and side surfaces with heat transfer coefficient H1 and H3 respectively. The average heat transfer coefficient for the cube H1 plus H2 plus H3. The bead flow equation through a cylinder of inner radius R1 outer radius R2 designed in the same form that the heat flow through a plane wall. The equivalent area AM is given by A2 minus A1 by log F A2 by ఉంచండి కొంచెం పాలు తెరాదు. స్టీఫెన్ బోల్ట్జ్మాన్స్ లా E equal to alpha E naught. Newton's law of cooling Q is equal to HF T1 minus T2. Laurier's law Q is equal to K by L T1 minus T2. Kirchhoff's law Q is equal to sigma A T2 power 4 minus T2 power 4. And description problems ఇందులో heat transfer rate per unit area conduction is proportional to the normal temperature gradient is called as Fourier's law. A physical property of a substance that characterizes the ability of the substance to transfer of heat, thermal conductivity is the ratio of product of thermal conductivity area and wall thickness is thermal conductance. Walls of several heterogeneous layers is composite. Mean radius for heat transfer by conduction through a hollow cylindrical of radius R1 R2 is the R2 minus R1 by log E of R2 by R1. Mean radius for heat transfer by conduction through a hollow sphere if radius R1 and R2 root of R1 R2. If delta T1 and delta 2 be inlet and outlet condition of temperature difference in heat exchanger, then log mean temperature difference is delta Ti minus delta T log E of delta T naught by delta T1. The ratio of product of coefficient of heat transfer and length and thermal conductivity is a Nusselt number. Heat transfer taking place by means of electromagnetic waves is the radiation. The sum of absorptivity, reflectivity, transmittivity is the unity. The value of alpha, rho and tau for black body R is equal to tau is equal to 0, alpha equal to 1. The value of alpha, rho and tau for white body R is equal to 1, tau equal to alpha equal to 0. The values of alpha, rho and tau transparent body is equal to value of for opaque body is the tau is equal to 0, R plus alpha equal to 1. relationship of black bodies between monochromatic emissive power and different wavelength is the Planck's law. The total emission from a black body per unit time varies directly as the fourth power of the absolute temperature is Stephen-Boltzmann's law. At the thermal equilibrium, the absorptivity, the emissivity are same. Thank you.